Hello everyone, I am Tanu Rajput and I came here again with my task 2. The task 2 is all about the prediction using unsupervised machine learning. Here we have Iris Dataset in which we have to predict the optimum numbers of cluster and represent it visually by using Python or R and then perform your task. So let's come to the dataset firstly. Here, let's take a look on the data set we have for the project. So we have many features, many variables like ID, sepal length, sepal width, petal length, petal width, all in centimeter. And then I have a dependent variable, which is a species, in which I have many species of a flower. Iris. Okay, now come to the code. As we all know that this project is based on unsupervised machine learning algorithm where we have to predict number of clusters. So objective of the task is to train the model to predict the optimum number of clusters and represent it visually. So what is unsupervised machine learning? It is also known as unsupervised machine learning and it uses machine learning algorithm basically to analyze and to cluster the data, unlabeled data. Okay, and these algorithms discover hidden patterns or data groupings without the need for human intervention. Basically, its ability to discover similarities and differences in information make it ideal solution for exploratory data analysis, cross-selling strategies, and customer segmentation and image recognition. Note, it is used to predict the categorical dependent variable. Okay, so now let's move ahead with our basic coding, and firstly we'll start with the importing Google Drive into the Google Colab, and here is the code. I have imported the Google Drive into the Google Colab, and after that I have imported all the required libraries for visualization for prediction. Okay, after importing libraries, I have loaded the data set, which is pd.read CSV. I load the data set by using Panda library, and here let's take a peek at the first 5 rows. Here we have ID, sepal length, sepal width, petal width, and our independent variable species. Okay, now let's take a look on shape of data set. Here we have total number of 150 rows with 6 columns, and in data information we can extract, we can tell that we have no null values in the data, and data type of all the columns are also mentioned here. Okay, after checking the information of data, we'll check is there any duplicate in our data or not. So after checking it, we get no duplicate in our data, and after checking duplicates, again I check the null values with easiest way, and in which I get the count of null values, that is df.isAny.sum. So we have no null values in the data set. After checking null values, let's see the statistical description of the data, which is df.describe .t. I use .t for a transpose visual. So here we have all the descriptions like what is the mean, what is standard deviation, what is the minimum number here, what is our median, and what is our maximum number here. So after digging deep into the description, we came to know that there is no outlier in the data set. So after checking all the description, statistical description, now it's time to see the correlation among all the features visually. Okay, so visually I can see that there are correlation between between petal length and petal width. Both the columns are highly correlated, but in sepal length and sepal width there is no correlation, means they are not so much correlated. So now it's time to see the data visually. It's time to explore the data. It's time to analyze the data. So I have drawn a pair plot for all the independent columns. So here we can clearly see that in some columns we have separate data, but in some columns the data gets overlapped. So to segregate that data, we need to cluster them. So to cluster them, we need some algorithm, and the algorithms will be used of unsupervised machine learning will be like KNN and dendrogram, etc., etc. So again I have drawn same plot, the independent and column via scatter plot with a histogram. Okay, now we can see easily segregate the data, but also there is some overlap data, so we have to use some clustering algorithm to segregate that data. So it's time to see the distribution of all columns. Okay, so here I can see that the distribution in sepal length is almost normalized, so it is normal. And in sepal width also we have a normal distribution. In petal length and in petal width also we have almost a normal distribution. So we see that almost we have normalized data, so we have no need to normalize it by using some transformation technique like log transformation, etc., etc. Okay, so now it's time to visualize the data with respect to their species, like Iris setosa, Iris versicolor, and Iris virginica. So here we can see that in green we have setosa, in blue we have versicolor, and in red we have virginica. So here is the presentation of virginica, versicolor, and setosa. We can see that setosa is separated from virginica and versicolor, but some points of virginica are overlapped with the points of versicolor. So it's time to modeling the data. For modeling data, first task is to separate the data like in independent and dependent variable. As we all know, our dependent variable is species and independent variable other than the species and ID. Okay, first algorithm of unsupervised machine learning is k-mean clustering. We'll use k-mean clustering and apply elbow method to get the number of clusters. So after applying elbow method into it, we get that we have a break in the curve at about 0.3, and so we can say that we have number of clusters 3 because we have a break in the curve at 0.3, so it indicates that number of clusters will be 3. But again, if we want to see the number of clusters with the help of dendrogram, then we can also say that we have number of clusters 3. So our objective of this task is to tell about the number of clusters, to predict the number of clusters for the data set. So as we have done, our number of clusters for the data set is 3. It's all about the task.